All right, Integrated Math 3 distance learning students. Today we're going to be talking about comparing functions. And in this second part of this first unit that we've been going through, I would say this is probably the more complex topic because it requires a lot of pre-knowledge. Okay, so depending on how well you understood the first unit, that's going to help you tremendously in this unit. Okay, so for those that are feeling a little bit behind and missed a few things from the last chapter, this video I'm going to go into detail about all of those small little rules that we've learned about last chapter. There's going to be maybe one or two new rules that we're going to be looking at, but your understanding of the characteristics of polynomial functions are going to be essential here. Okay, so when we're comparing functions, let me go ahead and have you write what we see here. So on your notes on the right side over there, title your notes with that, 1.2, comparing functions. And then we have this example over here on the right that we're going to be getting to. Okay, so, or excuse me, the left. So on the left, we have four functions that we're going to be comparing. Now I want to keep this as simple as possible. Again, it's still not going to be, it's not as easy as I'm going to try to make it, but we're going to try our best. We're going to limit it to three key ideas that I want you to be able to compare functions. Okay, and when I say I'm limiting it to three, these are the three main ideas that'll be assessed on your next test. Okay, let's write these down. So over here on the right side, we're going to write this down. So you'll write this in your notes. Questions we can ask when comparing functions. Now these are in no particular order. Let's start with number one. So we're going to say which function has the greatest least degree. Degree was a huge idea in the last chapter. Being able to find the degree of a function was very important. If you feel like you missed that last chapter, we're going to go over the idea of degree again in this example, and we'll try to make it click maybe now. Okay, let's go to the second question that we're probably going to ask. Which function? And in this case, we're going to put plural just in case. Functions has has an odd or even degree. So either or, odd or even degree. So a question, say on the test, may be, so going back to number one, a question on the test might be, which function has the greatest degree? And you're just looking at all four of them. Which question has the least degree? You look at all four. Which one has an even degree? Which one has an odd degree? And you look at all of them. Sometimes there's multiple that are even, sometimes there's multiple that are odd. And then the last one that I want to talk about, there's more, and some of the exercises we're going to look at in this video, it's going to ask for more stuff. Okay, so we'll just sort of go with it as they come on that one. But here is the last question: which function has the greatest least Y-intercept? All right, so how do you feel about these three questions? Do you think that you can look at a table, a graph, a function, or here we have a representation that is just a description, and try to figure these things out. Okay, that's what this whole topic is about. All right. So let's go. This is going to be our first example. So example 1. And I'm going to pause the video. What I'd like you to do is copy this into your notes right here. It's a box, and you'll notice that there are 4 functions, and they're named s of x, t of x, h of x, and v of x. Those are the 4 functions. So I'm going to pause it. You'll see the image on the pause. So just use that. Copy this down really quick. Okay, so we're going to answer the questions as we listed them up above, and this is how we're going to do it. So you have your drawing of all of these in your notes. Let's start with number 1. So we want greatest power or greatest degree. Okay, so notes for that. All right, notes for that. First off, degree is equal to the highest power. All right. Unfortunately, we don't really see that. That is for standard form, by the way. So I'm going to add that for standard form. All right. None of our equations here are in standard form. All right, so that's our first little note. Here's the next one. Degree is equal to the number of, I'm going to put it this way, real or imaginary roots. Okay. So these are really the main rules that we have that we've been going with. Okay. And that's all. That's been able to serve us fine. Now, when we get to these examples here, we struggle a little bit because now we have to extend this idea. We have to almost envision what these look like on a graph. Okay. Now we do already have the graph of this. We have our function that's graph. Now you'll notice that it crosses the x-axis once over here. Let me draw on this. So here we have a root right here. But that does not mean that the degree of this is actually 1. So in this example here, we have some imaginary roots. If you remember the lesson from parent functions, I think that in that video we talked about this. You should recognize that this shape is a cubic. Okay, x to the third. Now it's been translated and transformed in some ways, but it does look cubic. And what we have here is one real root, and then this right here is that idea of a multiplicity. But since it's out over the x-axis and it just crosses once, this has a multiplicity of 2 right here. So there's 2 imaginary roots, 1 real root. So the degree of this one is 3. Okay. So again, a lot of these, you're just having to think through what they look like. Okay. Now, this is in factored form here. All right, so this one's in factored form, and the roots are going to come from these factors. All right. And what we're looking for is, what would it be if I plug in certain values into these? If we plug in numbers, what will the roots be? Well, the roots will be, there'll be 2 of them. Okay. Now the roots aren't -1 and +2. This 6 actually messes up that process, but there's going to be 2 roots to this one. If you graph it, you'll notice that. So the degree of this one is 2. Right here we have, it says it's a quadratic function. Well, quadratics automatically, by that name, the descriptor means it is a degree of 2. All right, so what's brand new here for figuring out degree is going to be this table. We have not had to find degrees from a table before, and if you look at it, it's not very clear what it might be. So we're going to add a note over here. So we're gonna write down some notes for this. So finding degree from a table. And this is a very important skill for integrated math 3. We're going to write down some steps. We've never seen this before. I don't think you would have done it in iMath 2. So here's the first step. First step, you need to take differences. Let me actually rephrase that. Find the differences in the y values. Okay, now the y values show up over here. This is y, right? The xy table. So what is the difference as I go from 15 to 6? Well, I'm subtracting how much? That'd be 9. What's the difference as I go from 6 to 1? That's minus 5. From 1 to 0 is minus 1. And then from 0 to 3 is plus 3. So we're going to put those signs. So that is one row of differences. So we did that step 1. But step 2 is this: repeat until you get a constant row of differences. Okay, so continuing over here, what is the next difference here? So this is -9 to -5 is plus 4. -5 to -1 is plus 4. Okay, good. That's a constant. And then -1 to +3 is plus 4. So there we go. We have a constant row of differences. So what does this mean? Here we go. This is the rule we need. The number of rows it takes to get a constant difference is equal to the degree. All right, that's our rule. So on this one, how many rows did it take us? Well, it took us 1 row. It took us 2 rows. So the degree of this one is 2. So when we ask this question here, what is the greatest degree? That's what we wanted to know. Well, it would be which function has the greatest degree? That would be h of x, because it has a degree of 3. So that's the process. So for working questions, I just presented this to you. You're thinking through all these different ways to find degrees, like number of roots, highest power. What is the name of it? It's a quadratic, right? We know it's a quadratic. So all of that comes into play when you're thinking about these. It is a pretty complex process, and definitely practicing is going to get us, our best, expertise over time. This is not something that is just easy to do. Okay, so if you need to go back and look through that again, definitely do it. It's my cat. All right, so the next part of number 1 would be, what is the lowest? I'll write it in red. So lowest degree. So on this, we have multiple answers because they all share the lowest degree. So we would say S of x, T of x, and V of x. They all have the degree of 2, okay? So that would be like, that's what the first question would be looking like. Which function has the greatest, which one is the least? So on the test, it would be like a multiple choice, select all that apply type question. And you just need to make sure that you pick the right one, okay? Now let's talk about odd and even degrees. Doing the work in the first part helps us with the second part. So question number 2, which ones are odd? Which ones are even? So we've already done the work for this. We look over here, degree 3 cubic, that is an odd degree. So we're gonna say, this is h of x. And then which ones are even? Well, that's the rest of them, right? We've already seen that. So we're just gonna repeat, it's pretty much the same answers as we had before, because they have degrees of 2, so they're even. All right, next. Which function has the greatest and least y-intercept? It's the last one we're looking at. So number 3. Greatest y-intercept. And then we want least y-intercept, but I'll save that just in case we need to write a few notes here for this. We look at this, well, we can see right here the y-intercept for, change color here, the y-intercept on this one is -40. And if I look at another one, we go over here to the table. The table's pretty easy. That's where the x value is 0, so here's the y-intercept here, and it's +1. Okay, so right away we know that h of x doesn't have it. All right, how do we find the y-intercept for s of x? Because t of x is going to be the toughest. Well, let me erase this really quick. If I want to find the y-intercept for this, the fastest way of the function is to plug in zeros where x's are. It's going to be the most efficient way. And when we solve this, we're going to get 4 times 1 times -2 plus 6. And if we do that math, I'm going to pull up the calculator just because I'm out of space to like do the arithmetic. No, there it is. Okay. So we want 4 times 1 times -2. So that's -8 plus 6. So -2 is the y-intercept. Okay, that's where it's crossing the y-axis. So that's not it either. So our final hope here is with this one, because right now it's looking like it's going to be, it looks like it's going to be v of x. So here it says you have a quadratic function. A is greater than 0. So again, you have to remember all these small little rules from the first part of this unit. And a greater than 0 means that the concavity is up. So we know it's a quadratic. I'm just going to draw over here. You don't have to draw this. Or maybe you do right next to this. I'll actually draw it up here. So a quadratic with a value greater than 0 means it's opening up. Okay? We know that. So what that means is we don't, and it doesn't really tell us anything else. It says it has exactly one real 0. So what that means is it touches the x-axis once. So that means that here is, or the 0 is actually right there on the vertex. And if I draw my axes, it could look like this. All right. Now I could also draw it over here. There's nothing stopping it from having the axis there, and it could be anywhere because we don't really have enough information. But what that means is that the y-intercept, unless that 1 0 0 is at 0 0 or close to it, near around there, there's no way that it's going to be less. Okay? So on here, what we would say is not enough information. That is definitely going to be an answer choice on your test. Okay? So we're really trying to see how well you do at knowing what these characteristics are for these functions. So again, we couldn't make a decision here because we don't know where this quadratic's situated. We don't know if the y-intercept is going to be really a high number. If it was, it could go through a very high number, higher than 1. But if it is situated at the origin where that one real root is, then it's not. That'll be also the y-intercept, so it won't be. So we don't have enough information. Now, what about the least y-intercept? We do know that this function cannot have a negative y-intercept. The lowest y-intercept it can have is 0, so that helps us a lot. That means that h of x, with its negative 40, is going to end up taking this one, okay? That will have the least y-intercept, okay? So we're going to ask the exact same questions with another example. So I'm going to, we're going to let this one hang out on the slide here. So let's put example 2 in our notes. And we're going to go through the questions again. So example 2. This one has just 2 functions. And we're going to go ahead and start with the first question, which is which one has the greatest degree? And which one has the least degree? I'll draw explanations over here. So we're going to pause it and you're going to get to answer this question. So multiple choice, you're going to have 2 options, h of x or j of x. You see the 2 functions. You notice that the question says which has a greater degree. I want you to do both. But obviously if you get one, you get the other. Okay, so as soon as you figure it out, you'll know. All right, I'm going to pause it with the question, which one has the greatest degree? Okay, so when you're looking at this, a lot of times you want to maybe try to visualize it. So for instance, a polynomial function has one relative max of one relative minimum. That was last unit's concepts, relative max, relative min. What that makes me think of, and it could be opposite, but that makes me think, oh, it's doing this, right? Okay. Well, what do we know about a function like this? What is its degree? That's what we want to find out. Typically, the number of extrema is 1 less than the degree, or another way to phrase it, the degree is 1 more, so you add 1 to the number of extrema, which is the total relative and maximum minimums. Let's say that I had here's my x, here's my y. This is crossing 3 times. Now we can't guarantee it's going to do this, but if it did, it would have 3 intersections, which means the roots, there'd be 3, which is equal to the degree. So this looks like a cubic. So there's a lot that's telling me that the degree of this is 3. Let's look over here at the other one. Okay. So what ways can we figure this out? You could graph it to find the roots, but also through this right here is sort of the giveaway. We're raising this binomial to the 2nd power, and if we multiply this, that means our highest power is going to be that 2. So just by looking at that, the degree is going to be 2. So for this one, the greatest degree is going to be h of x. Least degree is going to be j of x. That's the thought process. So hopefully you got that. If you did, good job. Number 2, odd and even. Again, number 1 really does answer this if you're doing it correctly. So I'll pause it. You should have the answer to this. Let's see what you come up with. Odd degree. Let's just do odd. So which function has an odd degree? All right, so you should have picked h of x. That's what you should have picked because it's a cubic. We wrote down the degree is 3, and that's an odd number, so we're saying h of x. I meant to switch to red. There we go. Means automatically looking at j of x, it's a 2, so it is. All right, number 3. Greatest y-intercept. And least y-intercept. Okay, so I'll see what you think. All right, so on this one, since we don't know enough about this function right here, it doesn't tell us any information about its y-intercept. We could find the y-intercept on this pretty easily if we wanted to. You just plug in 0 and then solve it. I think it would be negative 40, negative 38, I think. But since we don't know much about the left one, there's just not enough information to make a conclusion. So not enough info. That goes for this as well. Because my graph over here could easily do this. Like I could have started boom, boom, boom. Okay? And let's say that this is the y, this is the x. And even though this is negative 38, this could still keep going. So there's not really a way for us to make this statement, okay? Because it could look like that too. So when it's not giving you enough detail about a certain polynomial, sometimes that's going to be the correct answer for these, okay? All right, we've got one more we want to look at. The delta math doesn't really offer a ton of practice for this. It actually doesn't have any. So, you know, that's something that's frustrating to me, and I wish that I had a way to get you more practice with this. And Mathia actually has a really good section over this. I know how much everybody loves Mathia, but I don't really want to get into Mathia really just yet. If I have to, I will, but we definitely need as much practice as possible with these. So I'm thinking about it. But let's go ahead and answer this. So let's start with number 1, greatest degree. And then least degree. So I'm going to leave it up to you. See what you can come up with. And go ahead and answer which one you think. You have B of X and C of X. Greatest degree. Let's just do greatest. All right, so let's think through this. And we'll see if you got it correct. So we'll go orange now. All right, polynomial function B of X with 2 absolute minimums and 1 relative maximum. So 2 absolute minimums. That means it's the lowest part of the graph. So I'm thinking absolute max, relative maximum, absolute minimum, up. Okay, so that's what it's making me think of. So 2 absolute minimums, 1 relative maximum right there. Okay, so that means that this one right off the bat, if we're thinking about question 2, even or odd, look how they're going the same direction. A lot of times that means that it is even. Okay, so right now we'll talk about the degree of this. Remember, how many times would it cross an axis here? Well, 1, 2, 3, 4. It has 3 turns to it, so we're going to say this is degree 4. Pretty high degree. We'll look at this. Well, let's see. We have this square here. Now, because these are being multiplied, we can't say that the highest power is 2. When they get multiplied, if we did a box method here, we would get our highest power. So we sort of are counting each one of these. This one gets counted twice, so 1, 2, 3. So the degree of this one should be 3. So what that helps us do is we're getting our answer over here. Degree is B of X. Least degree is C of X. All right. Number 2, odd and even. Let's see what you say about this. Pause it right now. All right, so the odd degree is going to be C of X. And the even degree should be B of X because it's 3 and 4. So C of X has 3, B of X has 4. And then let's do the y-intercepts. So we'll say greatest y-intercept, least y-intercept. Okay, so I'll let you answer which one has the greatest y-intercept, which one has the least. All right, so hopefully you picked not enough info. Just like the last example, we don't know anything about b of x. We're not sure what it's where it's crossing that y-axis, so we can't make a statement. Over here we could plug in 0. This would get us -2 times 3 times -4, so -32, -3 times, so it's 6 times 4, so that's 24, which is negative. No, it's positive. So it's something in the positives up there, but we don't know this one, so we don't have enough information. All right. So I hope to put up a little more practice on this concept. This is going to be the end of this lesson. It's taken a half hour, so if you have any questions here at the end, let me know. But I'm just going to go ahead and end it right there.